Hello students, hope you are doing good. Now without wasting time, let us start our topic of discussion, that is the motion chapter, this IIT Foundation ninth class physics topic. So what is basically motion? Motion is nothing but, in simple one word to say, motion is nothing but movement. Anything which is moving in this entire universe is counted to be in motion. So now when I say some object or some body or some point, if it is moving, now immediately the question you have to ask is with respect to what it is moving. For example, I'm standing still here. Now the question is, am I moving or not? So simply you will say that I'm not moving. But if the person who is watching directly from the sky, if he sees me, I'll be moving. So it depends on the observer whether the object is in motion or not. So basically motion and rest are basically, there are two terms which are relative. They are not absolute, they are relative. Okay, we'll discuss this. Now, so now if you just see this image, what is common in this image? Okay, you can just see there is a boy who is running, and there is an aeroplane which is moving in the sky, and there is a car which is moving. So there is something which is common. Okay, what do you all this have in common? So the common thing is, you can just simply say that objects are moving. Okay, so this person is moving, the aeroplane is moving, and the car is moving. So all are in motion. Now, as I told that earlier, when an object is in motion with respect to what it is moving, that is very, very important. So if I just say this person is moving with respect to some tree, okay, so tree is still there and this object is moving, the person is moving, you can just hear. So the aeroplane is moving. So aeroplane is moving means with respect to what it is moving. For example, there's a big tower. Okay, with respect to some tower, the object, okay, there is some radar is there. So radar will be at one particular place and the aeroplane is moving. So with respect to the radar, okay, or some antenna, this, okay, the aeroplane is moving at very high speed. Now similarly, this car is moving with respect to some pillar or something else. So the reference is very, very important. So one thing you can observe that in all these objects, the objects are not still, they are continuously, they are moving. Now when I'm saying moving, this person is moving, he is changing his positions. So this aeroplane is continuously changing its positions. So from one place to other place, they are moving, the objects. So basically motion is nothing but change in position with respect to time and to a chosen reference frame. So when I'm saying motion, simply you can't say the object is moving. You have to tell with respect to what it is moving. The first reference is time and the second reference is the frame of reference. We'll discuss this. Now you can just hear. So this concept of reference is very, very important for the physics point of view. From the physics point of view, whenever an object is moving or whenever an object is at rest, we always talk about these two important things. There is, one is the frame of reference, the other is the reference point, or you can simply call reference point. Now before that, okay, I'll just define this word motion. What is this motion? So yeah, so what is motion? As I told that, simply remember motion means, okay, this M for motion, okay, M for movement. So anything which is moving, M for motion and M for movement. Any object, any body or any point, anything which is moving, okay, with respect to time and chosen frame of reference. You can just see the definition here. Motion means change in position of an object. Okay, so in physics you can call object, you can call a body, you can call a point, whatever it may be. With respect to what it is moving is important. With respect to time it is moving and a chosen frame of reference. So to explain this, for example, you can just see there is a person here. You can just see there is a person here. So this guy, okay, for example, this guy is initially at say position A. Now this guy is moving or he's running. So when he's running, what he's doing is he's changing his position. So from position A, so this point I'll call as a position B. So from A to B, he has changed his position. So now the question is, with respect to what he's changing, with respect to time he's changing. Time stops for none. So time is entirely independent quantity and it's a scalar quantity. So this fellow, if he's moving from A to B, we say he's changing his position. With respect to time, he is changing. So at A, for example, this person is at this point A or position A I call, at time t is equal to 9 a.m. Okay, at 9 a.m. exactly the person is at point A. After some time, okay, at what time means, say for example, at 9:10 a.m. he is at position B. So what is happening is he's changing his position with respect to time. So I'm measuring his motion with respect to time. That is very important. So without time, there is no question of motion. So when I'm measuring motion, so I should mention some references. So the time is one reference, and apart from that, time is one reference, and one more reference is choose a frame of reference point. Reference point. Now, when I'm saying a reference point, so he is moving from A to B. With respect to what he is moving, one is the time. We are measuring the position is changing with respect to time. The other is, say, there is some pole here. Okay, there is some pole. There is an iron pole. So with respect to iron pole, this guy is moving. So with respect to iron pole, the person is at A. With respect to iron pole, he is at B. So from pole to A, the distance will be, say, some D1. From pole to B, say the distance is D2. So you can just see here. So if I say the person is changing the position, when I'm saying changing the position, the meaning is the D1 and D2, they will be different. So the person is moving. So these are reference. The reference is here, the pole. Okay. Or what I'll do is I'll just explain. Yeah. For example, this I'm calling as point A. The person is at A. Just understand this concept. This concept of time and reference are very, very important in physics. Okay, especially the IIT mains and JEE. Okay, JEE advanced and JEE mains. Okay, the physics. If you just see, they always talk about in terms of frame of reference and the time. So these concepts are important. So just pay a little bit attention, students. So the person is at point A, and this person is moving to point B. And from point B, the same person is moving to some other point, say some C. And from C, again he is moving to some other point, say some D. So continuously the person is moving. So what we say is the person is changing the position, we say. So initially the person is at A, afterwards B, afterwards C, and afterwards D. So changing position is good. With respect to what? With respect to time. So time is a one thing. So the person is continuously changing with respect to time and with respect to some reference. So what is the reference means? For example, so I'll just call this as some O. There is a point O. With respect to O, the person is at A position. With respect to O, the person is at B position. With respect to O, the person at C position. With respect to O, the person is at D position. So this is whatever the position I'm measuring. When I'm calling position, okay, what is position? Basically, it's a state. For example, I'm standing here. This I'll call A. For example, I have moved. Okay, I have standed here. Okay, I have stood here. So this I'll call position B. And I have moved here. Okay, so this I'll call C. So on like this. So exactly where you're standing with respect to this point O is called as position or state, we can call. So now what is happening is the object, the person is changing his state or changing the position with respect to the reference and with respect to the time. So time stops for none. So time is an important reference, and apart from this reference point O is very, very important. So now what is happening is, so without this reference, things will be incomplete. Of course, we are measuring with respect to time, but this reference is also very, very important. So motion is nothing but change in position of the object with respect to time and a chosen reference point. So the reference point is O here. So be careful. Now, Now when the, so this is nothing but the portion, okay, the person is in motion. Now when he is in rest, that is also important. So for example, the person is standing still. For example, with respect to O, there is some point E. Okay. With respect to O, everything, whatever I am moving, okay, I am measuring with respect to this point. Okay. So this point is called as reference point, or simply can call reference. Now, there is one more person who is standing at position E, I call, and that is I am standing at there with respect to O. Now, this person, he is standing, okay, the person A is standing at 9 a.m. at 9 a.m. at position A. After some time, he has gone to B. Okay. After some time, he has gone to C, and after lastly, he has gone to D. He has stopped there. So, after 9:30 a.m., he has gone to position D. Now, that fellow, this guy who is standing at position E, after, okay, both have started. Okay, let us take that this guy is also started at moving from time 9 a.m. So 9 a.m. he's standing there. After 10 minutes he is there. After 20 minutes he is there. Okay, even after half an hour he is there only. So what is happening? So this position E is not changing with respect to O, and the time is continuous changing. Time stops for none. So with respect to time, okay, that is time is continuously changing. Okay, from 9 or 9:30 or 9:10 or 9:20, whatever the time. But that fellow or that person is always there at position E with respect to the reference point. So I say that guy is at rest. And this person who is continuously moving, changing his positions with respect, okay, with respect to time and with respect to the reference, chosen reference, is said to be in motion. And that guy is said to be in rest. So hope this is clear. So now, so if you clearly see here, the object, whenever it is moving with respect to time and chosen reference, it is called as a motion. Now, the important question when you are handling this motion and rest is motion absolute or no? So very, very, very important. And clearly you can just see that answer is no. This motion and rest words are quite, okay, relative. They are never absolute. Now, what is this absolute? Absolute means all the persons, if some object is moving, okay, for example, if some stone is moving, if a stone is moving, let us say hypothetically, it is moving in some air, stone. Now, all the people in the entire universe, if they see the stone is changing its position with respect to time, then we say the motion is absolute. For example, one person is seeing the stone is moving, the other person is seeing the stone is at rest, then we say the motion is not absolute. So practically remember, the motion is not absolute, it is relative. So what is the meaning of motion not absolute or motion is relative? So remember this, motion is relative. So very, very important point which you have to note. Motion is relative. So what is the meaning of this? When I say relative, for one person, the object will be moving, the other person, the object will be at rest. A simple example I'll tell. For example, I'm going with my friend who is sitting next to me. Okay, in a bus we are going both of them, and I'm seeing at him. Okay, he just sat beside me. I'm looking at his face, turning my head. The person is beside me. So my friend is at rest, sitting beside me, next to me. And remember, we are going in a bus. And I saw outside the bus. Okay, that is out of the window I saw, window of the bus. All the trees, everything, they are going backwards. That means, am I in motion? Yes. With respect to the trees and all the objects or the shops outside the bus, I'm moving. But with respect to this fellow, okay, the person who is beside me, the friend, I'm not moving. So clearly we can just see the object, whether it is in rest or motion, it depends on the observer. That means, with respect to the person, okay, beside to me, I'm at rest. But with respect to the objects outside the bus, or with respect to the earth, so I'm in motion. So what is happening is, or I'll explain you in this way. For the persons, okay, I'm sitting in the bus. For the person next to me, the person is seeing me, I'm at rest. But for the person who is standing outside the bus, I'm continuously traveling, I'm moving in the bus. So for one person, I'm at rest. For the other person, the person outside the bus, he's standing outside the bus, he is watching me, the bus is moving. So for him, I'm in motion. So remember, so motion depends on observer. Inside the bus, I'm at rest. Outside the bus, okay, the person outside the bus, he is watching me, I'm going in the bus. So motion depends on the observer and frame of reference. So this is the point. Motion depends on observer and the frame of reference. Yeah. So it's a very important point you have to catch here. Motion depends on observer. For one person, it may be moving, the other person, it may be stationary, the object. And it also depends on the frame of reference. What is frame of reference? The same example I'll tell. Okay, the person, okay, we are going in the bus. So, on the bus which we are sitting, that bus itself is a frame of reference. There is one frame of reference. All the persons who are sitting in one bus and the bus is going, so they are in one frame. The bus, okay, the bus, whatever we are sitting, the bus itself will act as a frame of reference. Now, but the bus is moving on the road. That road is one frame of reference. So the person who is standing on the road and watching the bus will be moving. So the person standing on the earth, okay, on the road itself or the earth is acting like a frame of reference. So the frame of reference changes, the object, whether it's moving or not moving, changes. So motion depends on observer as well as a frame of reference. So this is a very, very important point which you have to keep in mind. Now, yeah, fine. Okay, just now I explained this concept. See here, for one observer, the object may be at rest, and for the other observer, it may be at motion. Okay, I'll just recap this. There are two persons. Okay, this is a person 1, and just this is a person 2, and there's one more person standing on the road. This is a person 3. So there are 3 persons, and 2 persons, they are moving on the bus. Okay, they are going to some place, and there's a third person. So this third person, or just let us say second person and third person are friends. The third person is saying that to the first person that the second person is moving, but the first person is saying that the person is not moving, he is sitting beside me. So who is true? The person 1 is telling that my friend is sitting beside me, he is stationary, he is not moving. But for the person 3 who is watching from the road, the person 2 is moving. So what is happening is, the observer, if he changes or the frame of reference changes, the motion or rest changes. For this guy, this guy is at rest. For this guy is at rest. But for this guy who is watching from outside, this guy is in motion because the entire bus is moving. Hope you are getting my point. So it depends on the observer. If the observer is standing on the road, it is in motion. For the observer sitting beside to him, it is in rest. So remember, so the meaning of this is, so the person is same, the person number 2 is same, but the who is observing, the first person observing, it is seeing that it is at rest. The third person is observing, the second person, he is at motion. So what is the difference here? The difference is the frame of reference, the first thing. The second thing is observer. So for the third person, the frame of reference is the ground or the earth. Okay, I'll just simply call earth or the road, whatever. But for the first person, the frame of reference is the bus. So the bus, so this is a frame of reference. Okay, on the bus they are standing or sitting. So here the frame of reference is bus. So the frame of reference changes, okay, the rest and motion, they keep changing. So this is very, very important concept which you have to know. Next. Oh, fine, just now I have covered this. Now the very, very important question which you have to think. Okay, now what I'm doing is I'm standing still. Okay, am I in motion or rest? What I'll do is I'll just stand in front of the digital board, okay, still like this. Now the question is, am I in motion or rest? You may be thinking that I may be at rest. No, I am not at rest, but I'll say that I'm at motion. Now how to understand this? Now see here, this earth, okay, earth is somewhat spherical in shape. Now on the earth I am in India and exactly at some place called as Hyderabad, somewhere here. Now a person in Hyderabad or beside me, if he sees, or the person, any person beside to me, if he sees me, I'm at rest, I'm standing like this. But the same person who is watching me beside to me, for example, is my friend, and that friend is watching me far away from the earth. So this is earth actually. From the earth he is going some thousands of kilometers above the sky, okay, above the earth. Somewhere here he is, the person is. Now from here he is watching. Now what happens? The earth is continuously, okay, rotating as well as revolving around the sun. So now earth is moving, so I am sitting on the earth, so everything is moving. So for the fellow who is far away from the earth, I am moving. Hope you are getting my point. I'm not still. For that guy, I'm moving. But for a guy who is just beside me, I'm still. Okay, hope you are getting this point. Now, so it depends on observer here. So if the observer is next to me, I'm still. But, or I'm at rest. For the observer, he is far away from the earth and he's watching me some thousands of kilometers away. The earth is rotating, so everything is rotating, so I'm moving, I'm not still. So it depends on the observer. So remember, that is what is important. Now, yeah. Now let us look at this. Okay, you can just see here. So somewhere I'm here. Okay, in this image, somewhere I'm here. Okay, on the earth. Okay, simple dot. But for example, let us assume that there is a person who is sitting inside the sun without burning. Let us say hypothetically, he is watching from here. Now, is the earth continuously moving? Yes or no? It's revolving around the sun. So I am moving here. I'm not still. I'll be standing, okay, in this studio still. But for this guy, I'm in motion. Okay, what is the speed? Okay, just here. If you just see, the earth moves at a speed of 30 kilometers per second. So for every second, approximately the earth is moving at a speed of 30 kilometers per second. For every second, I'm moving at 30 kilometers for this guy, with respect to this guy. But with respect to the guy who is next to me, I'm not moving, I'm still. Hope you're getting my point. Now let us understand the concept of distance and displacement. Fine, what I'll do is I'll just stop this session and let us continue the next session. Okay, this concept of distance and displacement. Thank you guys.